We often hear from AI teams in regulated industries such as healthcare and finance that they need better ways to explain their model's behavior in order to meet compliance standards. While large language models excel at straightforward tasks, they struggle with complex multi-step problems. This is where reflection helps. Reflection is a technique that guides AI through step-by-step reasoning. It breaks problems into smaller parts and verifies each step before reaching a solution. This improves both explainability and accuracy, making the AI's process more transparent and reliable. Today, I'm happy to share the release of Gretel's synthetic GSM8k reflection 405 billion. It is one of the very first publicly available datasets that can be used to experiment with reflection and is created entirely by Gretel Navigator. To learn more, visit our Hugging Face page. In this video, I'll show you two datasets we created with Gretel Navigator, one with reflection and one without. Each of them contains grade school math problems organized into different difficulty levels. Let's get started. First, let's take a look at the main execution block. The function run analysis takes one optional parameter. This parameter determines whether the analysis should consider reflections in the comparison. In the first step, I'll load the reflection and non-reflection datasets from Hugging Face. The sample and match function samples and matches pairs of problems from the reflection and non-reflection datasets based on shared attributes like difficulty or topic. Samples variable defines how many records to sample, and the include reflection flag determines whether to include reflection data in the matched pairs. I defined comparisons as a list where each entry is the result of LLMJudge Comparison for a matched pair. The LLMJudge Comparison function verifies that the generated outputs were of a high quality. Analyze Comparisons function processes the comparison list and generates two outputs: overall analysis, which is a summary of comparison results across all criteria, and segmented analysis, which is a breakdown of results by difficulty level, showing how a model performed on different types of problems. Last but not least, the function returns two values: overall analysis and segmented analysis. I'll call the run analysis function twice, once without reflection flag and once with it. Then compare the results and visualize them. Now let's scroll to the top and examine each function. To begin, I install the OpenAI and Datasets libraries quietly into my environment. Then I load all the necessary libraries, pass my OpenAI API key, and define the number of samples as 200. The load datasets function, as the name indicates, loads the reflection and non-reflection datasets from Hugging Face. The non-reflection dataset has 8 columns: difficulty, difficulty description, topic, context, age group, culture, question, and answer. The reflection dataset has the same 8 columns and an additional one named answer with tags. Let's inspect one of these examples. Maria is shopping at a department store during a sale where all items are 15% off. However, the store also has a special deal on coats, offering an additional 5% discount on the already discounted price. If Maria finds a coat originally priced at $120, how much will she pay for the coat after both discounts are applied? To solve this problem, let's break it down into multiple steps. First, Maria must determine the price after the initial 15% discount. The 15% of 120 equals to 18. Subtracting 18 from 120 gives her 102. Then, Maria should calculate 5% of 102. That equates to 5.1. This means the final price is 102 minus 5.1, which is $96.9. Now that you understand the dataset better, let's continue reviewing the code. The merge columns function takes a dictionary and a boolean as an input and formats it into a string. The include reflection flag is set to false by default, but when set to true, the answer reflection and answer output columns are also merged. The sample and match function matches both records between the reflection and non-reflection datasets and appends the matched pairs to the matched pairs list. The clean and parse JSON function cleans up a raw JSON string by removing markdown code fences, extra spaces, new lines, and trailing commas. The LLMJudge Comparison function uses OpenAI's GPT-4 model to compare two math problems, one with reflection and one without, based on 4 criteria: problem complexity, solution quality, educational value, and contextual richness. If the include reflection flag is set to true, it adds the reflection process to its criteria list. Then the function creates a detailed prompt for GPT-4, including the problems and criteria, and asks GPT-4 to provide a detailed analysis of each criterion and give an overall comparison in 10 words or less. The response is expected to be in a specific JSON format, and the function parses it and returns it for future use. The analyze comparison function takes a list of comparison results and analyzes the number of times reflection 1, non-reflection 1, and ties occurred for each criterion. It generates both an overall analysis, totals for each criterion across all comparisons, and a segmented analysis, totals for each criterion broken down by difficulty level. Invalid data is skipped, and warnings are printed if any issues are detected. To keep things short, the code refers to the reflection dataset as problem A and non-reflection dataset as problem B. Let's examine the results. For a hard question, problem A won overall because it offered deeper optimization and calculation practice. Considering each criterion, problem A won in problem complexity, solution quality, and educational value. At the same time, problem B won for contextual richness. For a medium difficulty level question, problem A won across all criteria and is the overall winner. I can also print the contents of the comparison list and take a look at it. In the final section, I have a function to summarize the results visually. The results are quite promising. Reflection won or tied 84.3% of all comparisons across all criteria and difficulty levels. This concludes today's demo. For the next steps, we plan to explore the impact of keeping the reflection tags for fine-tuning models versus just keeping the output. Our theory is that having an LLM explain its thought process helps reduce hallucinations, improve reasoning, and greatly increase auditability. So stay tuned. Finally, don't forget to join our Discord channel to ask questions and share ideas.